Hi, in this video I'll show how to train a neural network, first of all in C# and then afterwards using Azure Machine Learning and the Azure Machine Learning Studio. So I came to think of this, or I started working on this after having seen one of the sessions at the Build 2014 conference where James McCaffrey did a session on developing neural networks using Visual Studio. So if you haven't seen this session here, which you can find on channel 9, I'll recommend you to go ahead and do that because he's a really funny guy and the session is really good and gives a really good introduction into how neural networks work and how you can implement your own neural network in Visual Studio. So I actually went ahead and replicated or redid the example that James did in his presentation. He used a very popular dataset called the Iris dataset. You can find it here on the UC Irvine Machine Learning repository. And you can see it's actually the most popular dataset here. The dataset has four features regarding the leaves of these types of irises, and it's basically a classification problem. I went ahead and took his code and refactored it a bit and then applied this breast cancer Wisconsin dataset instead. I'll just quickly go ahead and show you how that actually works within Visual Studio. I uploaded all of my code to GitHub and I'll provide a link so that you can go ahead and download this code yourself and try it out for yourself. So basically this is a console application with a few different things in it. We have some input variables here with the source file, the number of input neurons, the number of hidden neurons, the number of output neurons we have, plus some parameters for the training of the neural network. We have some data generation here, some normalization using standard normalization. We initialize the neural network and then we actually do the training. In the end I show some results, and what I'm basically interested in is showing the accuracy of the network, first of all on the training data and then on the test data. So if we go ahead and click start here, it should run the program. So it already loaded the source file, normalized the data, initialized the neural network, and now it's actually doing the training using the backpropagation algorithm. It did that successfully, and we can see that the accuracy on the training data was 0.97% and the accuracy on the test data was 0.96%. So we have a fairly accurate model here which can predict whether or not a breast tumor is benign or malignant based on 9 characteristics or 9 features that were given to us in this data set. We could actually go ahead and take a look at this. This is freely available on the UC Irvine Machine Learning repository. If we click here on breast cancer Wisconsin, we can take a look in the data folder. We can take a look here. So this is a description of the data set that I was using, and we can see that the samples have arrived periodically during almost 25 years ago, and we have some attributes here. We have a sample code number, the clump thickness, uniformity of the cell size, uniformity of cell shape, some characteristics about the clumps here, and then whether or not it's benign or malignant. So we have a classification problem here, right? So a neural network is a good approach, or training a neural network is a good approach for estimating a model where you want to classify a problem like this, or where you want to do a classification problem like this one. And the code that McCaffrey wrote for his Build 2014 session could do exactly that. So what I'll show here now is how we can replicate that and do everything without writing a single line of code, because this neural network class that James McCaffrey wrote it's actually pretty involved. There's lots of stuff going on here, and if you are not a mathematician, or if you don't have deep programming skills, this might seem very confusing to you. But there's no need or no reason as to why training a neural network should be rocket science. Like, it's not that hard once you understand the idea. And you don't need any programming skills. You can use Azure Machine Learning for that. So I'll go ahead and show how to actually do it. Machine learning is a new service in Microsoft Azure, and you can see it right here when you're logged into the Azure Management Portal. The first thing you'll have to do is to create a workspace and then assign a Microsoft account or a Windows Live ID to that workspace. So I already did that. It takes a few minutes to provision. And when you actually do that, you'll have access to this Machine Learning Studio. And as you see here, it's still in preview, right? But it can do some pretty cool stuff, and I'll just show you one of the many things that it can do. So if you go ahead and click on an experiment to create an experiment. Oh, my session has expired. Let me just reload this. Okay, so if you go ahead and create a new experiment, you can see that I already worked a little bit on this Wisconsin breast cancer model here. We'll create it from scratch again, so you can see all the steps that are required to create this. But in here you can really see all the experiments you have running or that you've created, and you can create a new one pretty easily just by saying new in your experiment, and you have it right here. So you have this workspace here in the middle, and you can drag controls into that workspace and draw lines between each control, and then when you click run, all of these actions will be executed sequentially. So I'll just go ahead and call this neural network demo, hit enter, and then I'll start. So the first thing I'll do is to import a data set, and I'll just import this breast cancer Wisconsin data set that I got from the UC Irvine machine learning repository. If we go ahead and look at that, we can see that it's looks like a comma separated file with the ID here, the values of the features here, and then the classification variable here at the end. So it's either 2 for benign or 4 for malignant. I went ahead and created an AR FF file out of this. So rather than having this CSV file, I just named the attributes here, and that's actually the only thing I did. Azure Machine Learning takes both a CSV file and an ARFF file, so you don't really have to go ahead and do that data cleaning before actually dragging it into Azure. I just did it here. So we have a data source, and I'll drag that in here. So you can see that we have this data source. We could actually go ahead and visualize that, and we can see that we have some the ID here. Having a mean of an ID doesn't really make sense, but the mean of all these features actually do make some sort of sense, and we can see the distribution of each of these features here, and then here at the end the class, right? So we can see just 2 bars here, one high bar for 2 and a shorter bar for 4. So we have more benign cases than malignant here. So it's a really easy way just to visualize the data you're working with. Before actually going ahead and training the neural network, I want to apply some data transformations to my data set, and that's really easy to do directly here from ML Studio, and I'll show you how to do that. So the ID column that we just saw there before is not really needed. So the first thing I'll go ahead and do is to remove that column, and we can do that by saying project columns. I'll drag this in here, I'll establish a connection, and then I'll say, okay, start with all columns but exclude the ID, and I'll just say okay. So this will take this input data set, it will run through this action here, and it will just exclude the column ID. Great. The second thing I would like to do is to revalue or manipulate the value of the class variable, because rather than having 2 for benign or 4 for malignant, I'd actually like to have 0 for benign and 1 for malignant. It will make sense why I want that later on, but let me just show you how you can do that. There are different ways, but since this is a numerical value, I'll just go ahead and apply 2 math operations. So I'm dragging a math operation here. I'll do an operation, and I want to divide first of all by 2. So all the 4s will be 2s and all the 2s will be 1s. By standard, this will be applied to all of the numerical values, or all of the numeric columns in the data set. But that is not what I want. I just want to do it on the class variable. Right, so I'll just do that. So this math operation will only be applied to the class variable. Then I have to select the output mode here, and there are 3 different options. Either I can append this new column that will be generated to my data set. I can just output the result only, or I could do an in-place output mode. And in-place basically just means a replace of the current value, and that's what I want. So I'll just say that. I'll apply another math operation, and this time I'll say subtract 1, and I'll do that just for the class variable, and we'll say OK. I'll select in place, and now if we think of it, I first of all removed the ID column here in the project columns action. Then I took all of the class variables or class values, I divided them by 2, so all of the 4s would be 2s and all of the 2s would be 1s. And then after that I subtracted 1, so all of the 2s would be 1s and all the 1s would be 0s. So here, down here, I have a data set without an ID column, and where the values of the class column now are either 0 for benign or 1 for malignant. Next step then is to remove the missing values or the rows with missing values in the data set. And I'll actually show you that here in Notepad++. So if we skim through the data set here, we can see that there are actually some rows, for example here row 56, where there is a missing value. We see that question mark right there, and that's not good. We want to do something about that. We don't want a missing value in our data set, and so we can apply this action called the missing values scrubber. We'll create a connection here, and then we can do some different things. We could either just replace the missing value with a constant, for example 0. We could replace it with the mean, the median, the mode, or we could just remove the entire row. Since I don't have that many rows with missing values, removing them is not going to be that big of a deal, so I'll not lose a lot of my data by removing the rows with missing values. So I'll just go ahead and do that. That's by far the easiest. So that's really just all you have to do to scrub out or to remove the rows with missing values. It's really easy. So our data set is getting cleaner and cleaner as we are applying more and more actions here, right? Good. So I want to do one last thing before actually starting to train the model, and that's I want to normalize our data. So we have here somewhere, let me just try and look it up. There is a let me see. There is a action here that's called transforming by normalization. There are a bunch of different actions here, so it's a little hard to actually find it sometimes. Let me just look up what it was called. Transform data by scaling. Yeah, okay. Transform data by scaling. Good. So this action here can take some data and it can apply some sort of scaling or normalization to it. So what I want is to apply the Z-score or the normalization of the data, and we can select on which columns to do that. So I want to do that to all columns except for my class column here. So this normalization, this z-score normalization, will be applied to all columns except for the class. Great. So just here in 5 steps, I've taken my original dataset that came more or less just directly in a raw format from the UC Irvine machine learning repository. I then removed one of the columns, applied some math operations, removed the missing values, and normalized it. And now we're ready to actually go ahead and create a model and train it. So if we take a look here at the machine learning section, we can see that we can initialize a model, and we have 3 different models we can go ahead and initialize here, either standard regression, clustering, or classification. Since we want to classify whether an observation was either benign or malignant, we have a classification problem. So we can take a look at the options that we have here. And there are a bunch of different ways. Some of them are typical or traditional statistical methods. For example, the 2-class logistic regression they're basically models coming from a statistical world. We also have the neural network here, which is the one we'll be working with. But just before that, I want to show that you can actually work with any kind of model and plug it in the same way. And if you want to replace your model with another model, it's really easy to do so. So here I'll actually first of all apply this, I'll work with this logistic regression model, and what's under the covers, or what's actually inside of this box, is a logic model that will be estimated using maximum likelihood estimation. If you don't feel too confident, or if you want to learn more about what are actually inside of these different boxes and what they actually mean, I can recommend Wikibooks. They have some really good resources on these topics. So here we are. I've found this article on binomial models, and specifically we're talking about the logit model here, or the probit model. So the logit model is actually what's inside of this box right here. We can specify some parameters for that, but I'll actually not do that. I'll just leave these values at their default values. So with that value, or with that model right here, we can go ahead and train, and it's really easy to train a model. You just grab this box right here. The first input is the untrained model itself, and then it's the actual data set. So we can go ahead and connect that one to here, and take this data set right here. Whoopsie, we have here a connection to the trained model. We'll just have to select what it needs to be training, and that's, or what is actually the class and the classification column that it needs to, well, what's actually the output column here, and that's the class. So we'll say OK, and we have everything set up now to train a model. I'll just go ahead and do a few more things before actually running this. I would like to score the model also. So we can score a model using a trained model. That's what we have right here, and then a data set. So this data set will be, you know what? Let me just try and see. You know what? Actually, I think I'll go ahead and apply one more step before doing this. I think I want to split up my data set into a training set and a test set, and we can actually do that really easily with another control. There is the split control here that will apply like this. So if we go ahead and make this split, we can see that this takes an input of a data set, and it outputs dataset 1 and dataset 2. So it basically just takes an input dataset and splits it into 2. And you can do that in a randomized manner by clicking this checkbox. So the first data set will be our training data set, and I want that to be 80% of the data. That's a typical fraction, so that you would take 80% of your original data and say that's your training set, then the remaining 20% would then be the test data. So I'll take 80% of the data, use that for training, and then later on when I want to score the model, I'll score that using our test data set. So this first arrow shows the training set and the second arrow shows the test data set. Good. This outputs another a scored data set, and we can go ahead and write that out to a CSV file. So we have this writer right here, and this guy takes a data set as an input, so we can just go ahead and make that as connection. We can write either to an Azure table that's in table storage in Azure, or an table in Azure SQL databases. We can also write it to a Hive query, but I would just want to dump this out into a CSV file, so I'll go ahead and do that in the blob storage. My account name, you can find your account name, or you can create a new storage account here in the Azure Management Portal. I have an account here called ML Stuff, so I'll just use that account. So I'll enter the name here. The account key can be found, the account key can be found by clicking on this button here. I won't go ahead and do that because I don't want to show my keys here in the screencast, but you can find your account key there. And since I already entered this before, I guess that Azure Azure ML already knows my key, so it just entered that value for me. I'll have to specify a path to where this CSV file should be dumped, so I'll just I want that to be in the results container, and let's call this score.csv. Good. We're almost there. So other than scoring the model and outputting the scored data set to a CSV file, I also want to do an evaluation of the model. I want to see how good my model is. And there is an action for that. We can drag in here the evaluated model. It takes a scored data set as an input. Good. Well, we have that right there. We could also input another scored data set to compare if we wanted to do a comparison of two scored models, basically. So this is the first one here is a required input, and the second one is just an optional. Since we don't have another model to compare with, I'm not going to go ahead and use this optional parameter. The evaluation results can then also be outputted, and I want to do that in the same way. I want to write it out to a CSV file in my Azure blob storage. So I'll take another writer here. I'll establish this connection. I'll write ML stuff. It knows my key, and let's say we'll call this eval.csv. Great. So I'll zoom out a little bit so we can see our whole model. And we can see that we start out from the top here with the data set that I got from the UC Irvine Machine Learning repository. I remove one of the columns with the project columns action. I apply it to math operations. I scrub out remove the missing values. I normalize the features, and then I split the data into a training set and a test set. I'm using the two-class logistic regression model, and I'm training that model with this training data. I'm scoring it, evaluating it, and writing out the output to CSV files and blob storage. So if we go ahead and click Run, we should see everything come together. Yep, and we can see a small clock next to each action here. These will gradually turn into green check marks if everything goes well. So we can see that things can actually happen in a parallel fashion here. We had the model created here, and we have this sequence of operations going on here. The model can't be trained yet, even though the model here is ready, because the data isn't ready. So we still have to wait for these actions to be executed. So we're waiting for the transform data by scaling, and it should Should not take that long. I don't know what's going on now. Okay, yeah, so here we go. So we have the data ready. It's training the model. This is the most, this is the heaviest of all of the tasks. So we see that small circle spinning around. And it takes a little bit of time. And boom, boom, boom. So everything happened really fast there at the end. So we see green check marks all over the place. And we should now be able to see two CSV files in our container. I'll use Visual Studio to browse my container. I have it open here already. So if I click refresh, we should see these two CSV files. And indeed, we have them right here. So first of all, I want to take a look at the evaluation of this model, and I'll just double click on this to open it in Excel. And we see some values here. These don't make a lot of sense without any labels on them. So you can actually go ahead and click on this action, and then click on the help button out here to see what it actually outputs, to get a better understanding of what it actually does. I think that didn't. Oh, here we have to click on more, right? So it says here that the evaluate model evaluates the performance of a scored binary classification or regression model by generating evaluation metrics. A scored binary classification model can be visualized using utilities built into ML Studio. That's great. For classification models, evaluate generates accuracy, precision, recall, F-score. So remember, this is we use the logit model, right? So this is a statistical score that came out as a result of this of estimating the model. The AUC, the average log loss, and the training log loss metric. So the first one here is the most interesting one, and we can see that that's actually at 0.978, which is a really high score, right? And we saw before when we actually applied or when we ran and when we trained the neural network implemented in C# here, we also got a high score. So this data is very suitable for modeling and for estimating in the model, as we can see. So that's really good. We can also take a look at the scored dataset. So I'll just double click on that. And here we see all of the observations, in the training data. So we have about we have 137 here, and I should actually have written this out with header columns. You can see here in Visual Studio, when you write this out, you can write a blob, a header row. If we had done that, we could see what each of these values would have meant, or each of these columns, the names of these. But I'll just tell you. So this here is the actual class column, and this here is our scored label, and this is the actual output of the logit function or the logit model. So we can see that we were actually pretty good at estimating or guessing or predicting what was going to be the value of the class column based on these features here. And actually, if we go ahead and calculate an error here, if we calculate the sum of errors, we can do that by saying this by minus this, and we do that for all of the rows, and we do a sum from M1 to M137. We can see the sum of errors is actually just one. There was just one case where we did not estimate the class to be the right class, right? We didn't estimate whether it was benign or malignant, and that was actually in this case right here. So, or there were a few more cases basically. I guess I should just take the absolute error here. Well, the idea is just to say that this was actually a pretty accurate model. We were able to establish or estimate a very accurate model, We did that using the logistic regression model. We can do that as well using a neural network, and it's so easy now that we have everything set up. So rather than using the two-class logistic regression model, I'll just train a neural network instead. We have some different parameters. It comes with some standard or with some default values, and there are rules of thumbs for setting each of these values. We could go ahead and just work with the default values, but I think that for our case the number of hidden nodes is a little too high. The rule of thumb that I've been working with, or that I usually work with, is taking the sum of the input neurons plus the sum of the output neurons and multiply that by 2/3. If you want to learn more about these input values here, or these parameters that you can work with, once again I recommend you to take a look at Wikibooks, and there's an article here about artificial neural networks, and especially the basics of neural networks. And it will give you some. It will also give you some good rules of thumb to work with. So I think in our case, since we have 9 input neurons and just 1 output neuron, we'll take 2/3 of that. So let's just say 6 hidden neurons. That'll be fine. I'll leave these values to default. In our case, it doesn't matter that much, but you can play around with it, and you can read a little bit more about what they actually mean on this resource that I showed you before. But for now, this will work fine. So I'll go ahead and delete these 2 output CSV files from before. And I'll train the model one more time, this time not using the logistic regression model, but using an actual neural network instead. And it will have to go through all of the steps one more time. So we'll start here from the top. We already see some green check marks here. You'll apply the math aberration, remove missing values, and we'll normalize the data. It takes a little bit of time. And we are down here to actually training the model. It's usually the longest task. Oh, it was quite fast there. We'll score the model, evaluate it, and write out the results. Let's see. Good. Everything completed, and we see green check marks all over the place. So we should be able to go in here, click refresh, and see our 2 CSV files. I'll open the eval CSV file one more time. Oops, I can't do that since I already have these workbooks open. I'll just close these and not save them. So I'll open it again. And it's downloading, and here we're starting it. So we see the same metrics as before, but the values have changed slightly. Still, we have a very high accuracy of 97%. So we're scoring almost equally as high as when we used the logistic regression model instead. We can take a look at the actual scored data set. And once again, we see the same columns, and we could go ahead and calculate the sum of errors if we wanted to do that. But generally, we can see that there's a good match between the actual class value and the scored class value. So, yeah. So this is really how easy it is to train a neural network using Azure Machine Learning, and how easy it actually is to interpret this data. It's still in preview, so there's a lot of things still going on, and new new actions that will come here, and things that will be optimized. But you can already go ahead and use this. It's already a pretty solid product, and I've had a lot of fun working with this in its preview period so far. Yeah. One last thing I want to mention is a book that James McCaffrey wrote. It came out about a month ago, or a little more than a month ago, and it's titled Neural Networks Using C#. It can be downloaded for free, either as a PDF or in Kindle version. And in the book, James is explaining in further detail how neural networks actually work, how the back propagation algorithm work, and all that. So I can recommend checking this out, and I'll provide the link for that. So thanks a lot for watching this video. I encourage you to go ahead and try working with Azure Machine Learning. You can sign up for a free trial on Azure.com, and yeah, have fun with it.